for the next 15 minutes, I really want you to stop thinking about code. There's not going to be a single line of code in this session. I'm not doing live coding or anything. You're not going to see databases because I know most of you are developers, correct? Yeah, and this is the time to sit down and really go back to the drawing board and reflect and think about architecture for once. Any cloud architects or solution architects? Thank you. Hello, nice meeting you all. All right, I think we're all good. Yes, and I'd like to introduce myself first. My name is Marilag Svennevig. When I was here the last time, it was still Dimatulac. I got married in the meantime, so now I have this fancy surname, Svennevig. And I am a cloud architect, and I'm also a tech entrepreneur. I started my own company back in 2016. It's called Device, and ever since then, we have been building cloud-native applications. And while I really love talking about technical topics and architecture and pattern and the latest in cloud, my real passion is really for the people behind tech. And that's why I'm very active with a lot of different tech communities. And about a couple of years ago, I also started a nonprofit organization called ulap.org. It means Underserved Youth Learning Assistance Program, where we actually help underserved college students get free training in Azure, AWS, Google, Alibaba, and then get them certified so that you can help them kickstart their career. So if you're interested in supporting us, please, get in touch. So whenever I pick a technical topic to learn, to go deep dive into, to share, I really want to focus on the problem that I want to solve. And there's a lot of problems in the world that we want to solve, especially as cloud architects. But recently, and I've got to be honest, that's why it's a shame I couldn't attend to Stacy's talk, which is tomorrow, which is all about managing your anxiety. I've had anxiety also back like years ago, 25, when I was 25 years old, and I was also still working as a developer. But then my problem right now is I'm getting a little bit frustrated with the whole tech profession, and I'm just being very honest. Maybe it's because 20 years of developing, I'm starting to think, is there really a formula for success for building solutions that actually works well and can sustainably work well? Because a lot of the ones, at least that I have experienced and seen in the industry, regardless of the size of the industry, they turn out to be problematic, right? Maybe not at first, but then, as your features grow, as more people start using your application, then the problems start showing up. And whenever these problems present themselves, there's seem to be just one word that to be blamed. Can you guess what that word is? If something is not working, something is breaking, and people are unhappy, what is the word that they blame that issue to? Architecture. Do you agree? It's like, oh, it's bad architecture. It's bad architecture. They're always blaming us architects. So I come to think, is cloud architecture really that hard? Is it really that hard? Is that really the root of our problems, bad architecture? And if it is, can we solve it? But why is it hard? So one thing that I really, and I think you can all relate, doesn't matter if you're architecture or you're architect or you're a developer, the one thing that's really difficult with building anything, digital product, is trade-off. It's always all about trade-off. We all want, and I trust that you all want to build good applications, but you have to work with a lot of constraints. And that's why you have to make these trade-offs. And most of the time, these constraints are actually rooted in financial constraints. Do you agree? It's all about money, money, money. No, I'm saying it's reality, right? We want developers, we want to build good code, we want to do all the fancy, test-driven development. We have to run all our application with high availability, if it's mission critical, all these things, but it requires money. It requires money to hire the good people, it requires money to train people, to sustain people. It's very expensive. So what we do is make those trade-offs, thinking that, oh, we will save on cost for now, not knowing that those compromises that we're doing for not really making the right decision upfront will anyways incur much more cost in form of technical debt. And this is why architecture can be really scary. Those decisions that you didn't make, that you compromised, accumulates into technical debt. And actually, according to one study in the US, the cost of poor software quality in 2021, I think, is a whopping $2.41 trillion, people. It's a lot of Chanel bags for me that I can't buy because it's a lot of money. And this is just, if you look at the Consortium for Information Software Quality, they have this study. And this is because of bad quality software, probably because of all those accumulated technical debt. So if the next time you go and talk to the business and say, no, I don't want to buy that tier, you know, it can cost us trillions if we don't do it now. No, but it's reality, and it's not just the technical debt. A lot of, you know, also the pain, a lot of the projects that we embark into, 65% of them are gonna fail. And that's why I'm a little bit frustrated. It's like I put all my heart into this software, into this application, into design, but 65% of them is going to fail. And due to, again, maybe bad architecture, wrong choices, again, lack of money. That's why I made these slides colorful, because it's a little bit sad, my talk. So I wanted to compensate with purple colors, because 19% of the applications are anyways going to be canceled. It's a lot of resources burned because we don't really put ourselves into thinking about the architecture of our solution. And one thing is money, but then it's also costing us all our mental health, our, you know, limited cognitive energy, and we burn out. And we all do experience that. We recognize that. I've experienced that. But I have my own company, so unfortunately I can't just stop, because if you stop, my company goes down. So I have to just really work. So I really wanted to find how can we get out of this. And if you're familiar with, you know, the DevOps, State of DevOps report, have you read the latest one, the 2022 one? It says that burnout is much correlated with unstable teams. And unstable teams are those that are low-performing teams, and only 11% of us are building software with high performance. And high-performing teams is highly correlated with good architecture. And good architecture, one of the biggest driving factors for good architecture and for high-performing teams that makes us all happy and make us less burnout, is cloud, investing in cloud, building cloud-native applications, using also automation and, you know, all the fancy things that you can think of about cloud. Do you agree? Everybody builds applications in the cloud nowadays, or are still building in mainframe developers still? Okay, well, that's pretty cool. I'd like to try that one day. Yeah, but so how do we solve the problem? Cloud? Is it really the pill for good architecture? Just put everything in the cloud? Shall we just all learn Kubernetes and we'll all be happy? I don't think so. Because one of the things that we also do not consider when we start building cloud-native applications is something that is not new to cloud. This is the concept of the 8 policies of the distributed systems. Anybody heard of the 8 policies of the distributed systems? It's actually a term coined by L. Peter Deutsch, I think back in the 90s, when people start, you know, architecting solutions with client server or 3-tier or in-tier, and moving away from the whole monolith and then decomposing all the solutions. But some of these policies are the wrong assumptions architects and developers make when they're building distributed applications. And what we're building on the cloud is, or the cloud is just one massive distributed platform. But we don't consider some of things, or we make the wrong assumptions when we build the system. And these are the 8 policies. That's very, you know, well known. So the network is reliable. When we decompose our solution or make them loosely coupled, we just build them and think that we can start connecting service A to service B, and that is always just going to work. We forget the fact that sometimes service B is not there, it's not available or something. But when we don't design for that, then we forget that the network is reliable. Latency is 0, it is not. Bandwidth is infinite. It's still not, even though we move to the cloud. So when we build applications that pushes, you know, large amount of data into the wire, you're going to have a problem if you don't really think about what you're pushing out there. So we are still at the mercy of some of the physical limitations in the cloud. The network is secure. It's probably something that you don't have misconception, you don't assume anymore, I hope, right? But back in the days when they were building these distributed applications, they just automatically think, oh, this is an internal application. No one's going to inspect what's happening under the hood in the network. But the network is not secure. And I still hear some people, some of them still also technical people, some business is like, why do we need to do all this security? Isn't that already running in the cloud? Isn't Microsoft or AWS responsible for securing all this? Not really. We also think that in the distributed application, the topology doesn't change. It does. DNS records doesn't change, routing doesn't change, it does. Even the small, physical disks and servers inside a rack in the data center sometimes change. You get a firmware update, something can go wrong. So if you're rebuilding applications, you have to really take these things into consideration. Well, this one, I don't know if this applies. This is back in the 80s where people think, oh, there's only one person who's in charge of everything and who knows everything. Well, in the cloud, nobody, you can't just point to one person and make sure, oh, Steve, can you fix that network inside this data center? There's no one. You don't know anybody. And that transport cost is zero. Everything, every single digit we send out into the physical world of cloud has a cost, right? So we better think about what we're doing, what we're sending out there. And then the network is homogeneous. This is so untrue already for the cloud. There's, especially with the concept of microservices and then also different, SaaS applications, dependencies, all this multitude of technology and platforms that we have to learn. It makes things much more complicated for us. So if you don't design for it up front, we're going to have lots of problems. So luckily in Azure, they have also published the 10 design principles that can help us mitigate some of these fallacies. And what I'm saying now, before I present this, is like my feelings about design principles is that it's important to be aware and understand them. But wait until you really understand what your application or workload is really trying to do. And I know that this sounds cliche, but then if you put a POC and understand, oh, okay, I actually have 30 different services or small microservices that talk to each other. Now I can think about design patterns. Having that awareness and understanding instead of obsessing about the design patterns up front, which is likely to change once you understand how your application and workload is running, better yet be aware of them, but then don't let it block you. That's what I'm saying. So on the Architecture Center, they published like these 10 design principles, primarily for application design, but it can also apply for your whole, application platform design and pretty much any kind of workload and aspect in your cloud architecture. So the design principles, you have to design for self-healing. I know that this is pretty advanced. This requires a team that can understand how to create automation scripts that can scan all the resources and all your workloads and application and understand, or run some health check. Oh, is this failing? What am I going to do if this one is failing? I cannot, for some reason, if I pinged server A, I cannot service or endpoint A, I cannot find it. But then what do? Do you call someone, hey, Stacy, I can see service A is not running. Can you have a look at it? Who's in that scenario still? Come on, don't be shy. I am. Hey, Stacy, can you see why this is returning 502 and not 200? But the self-healing is to be able to maybe figure out and run some remediation so that it can automatically go back up. And if not, that another healthy service will go back up automatically. And so something that you need to really consider that make everything redundant. And I will share some of the key lessons that I learned when building a highly distributed application. But then since redundancy is something that we don't have to do right away, but have to really think about upfront. So we build an application, say, oh, let's just deploy that in the single region, that's fine. But as it grows, we realize that we can't just depend on. So for instance, like analytics fail in West Europe, and then the whole application stopped working because we're all dependent on log analytics. For every write transaction, we actually write it to the log analytics for auditing. And when Azure had an outage with log analytics, everything went down. So what can you do, right? So, and that's the same with other endpoints. As I had some point where Cosmos DB in one region also went down. So you need to design for redundancies. This is another thing, minimize coordination, because in the last, 5-10 years, we were all now being indoctrinated to build microservices, not really realizing the complexity of having to coordinate and orchestrate all these different, not just on the network and physical level, but also the domain problems that each of these microservices is trying to solve. And then if they're doing it in isolation, and then you need to, at some point, coordinate them. So if one fails, you also have to do some compensation in the other service. This is a lot of things to consider. So before you build, like, I don't know, 1,000 microservices, think about how would you like to coordinate that. Design to scale out, not just to scale up. And scale out is also quite interesting. So if, like, for example, even in our experience just building an Azure function one time, but then it's auto scale, then we had an experience that the newest code, latest code is already running in one instance and not on the other instance. For some reason, it didn't have a successful deployment. So the other client that's connecting in a different instance that had an old code running into it was getting a different behavior, and we couldn't really trace that until I figured out, oh, like the instance ID is different. So maybe this one is unhealthy. But that's the trade-off for wanting to make it scalable and doing scale out. Partition around limits, and this is like if you have your data, for example, and you wanted to design the partitioning or the sharding of your data, you have to also consider, oh, okay, I'm selecting this particular partitioning strategy because I know that this is my workload, this is how much my write transaction is, my read transaction is, and this is gonna fit for this particular logical partition, which is backed by an actual physical partition where you have still, there's nothing out there other than storage and compute capacity and input output, right? So you have to really think, what is my use case so that I can partition my data well? There's a lot of other design principles. Design for operations, for the people that will actually deploy and maintain your solutions, your backup. Use managed services. This is a design pattern, of course, coming from a cloud vendor, that as much as possible, go for the PaaS or the managed services. It's just gonna take away the headache. But of course, that's with a caveat, right? Like, not because we're using managed services, doesn't mean that we don't have anything, we're at any responsibilities anymore. Use the best data source for the job. So I really love, one of the things that I really love about cloud is that we're able to do polyglot databases or polyglot data stores, that you can actually pick the right data store for the job. So if you're dealing with structured data or semi-structured data or non-structured data, you have a wide choice. You don't have to lock yourself in one data storage. Design for evolution. We all know that, we've experienced that. We've been in the industry for as long as we can remember. Things change. And lastly, the most important is build for the needs of the business. And all of this design patterns is neatly packaged into guidelines and documentation and tools that you will find in the Azure Well Architected Framework. So who has used the Cloud Adoption Framework, CAF, for designing, for deploying all your landing zones, which is really good when you're about to migrate your existing workload from on-prem to cloud, or you are adopting a cloud-native strategy. But the CAF is very, it's very opinionated. It's very highly engineered already to minimize the learning curve for people who wants to just start becoming productive and gaining value from the cloud. WAF is a bit, the word framework, it's not very prescriptive. Sometimes it turns into philosophical when you read the documentation, but it does certainly give you a starting point to really how to design your solutions based on the 5 pillars, which we will go through later, the 5 pillars of the well-architected framework. But other than explaining to you all these pillars, I also want to focus on who are supposed to design, who are supposed to make the architecture decisions. What are the roles that you have in your organization? How do you do architectural change management? How do you document and record all this architecture, because that's a big problem. So what is the life cycle? What are the minimum and most important matrices that we want to focus on across these pillars. And maybe if we have enough time, I can share a case study of how I built, I'm part of a project that has built a cloud engineering portal, a self-service portal for a really large company that's migrating everything in the cloud, where they have about more than 3,000 developers and 500 digital products that they want to build, and what I have learned from that. Is it okay? Can you hear me okay? I'm trying to save my voice because I want to party tonight at the after party. But I'm on an alcohol-free month. Unfortunate. Why did I do that on February? So I can't have wine. Right. So what I said, who has gone through the WAF, the Well Architected Framework document? I guess a lot of you have probably come across. I don't know if you read the whole thing. You can download the PDF if you want, and then you can go to your room and cozy up with a blanket and read the whole thing in one evening. I don't mind. That's your thing. I would do it if I could. But it's a lot of documentation. Be careful not to get over obsessed with all the information that you get there, right? So good thing is pick one of the pillars. That's my advice. So, but aside from the documentation, it's also neatly arranged so that you can directly not just go through the pillars, but another entry point is to pick the actual workload that you want to build. So for example, you're building an IoT, or you're building you want to see or be inspired for an architecture for something that's mission critical, or for finance system or health system. So you would find some reference architectures, and then it also nicely links to the actual documentation on how to configure using best practice the specific Azure resource that is involved in the architecture that will be recommended. So that is the framework. So what are the 5 pillars of the Well Architected Framework? I think a lot of you must have seen this already, I hope. And so this is cost optimization, performance, reliability, security, and operational excellence. By the way, so WAF has been released in 2020, but it has been updated a lot. I think also the names of the pillars has changed, but it's continuously evolving. We can't say that when I read this in 2020, it's still the same. A lot has changed in the cloud. And it's not also unique to Azure. AWS and Google, I think they have their own WAF, and one of the things that you really need to consider, of course, the well-architected framework is centered on the vendor. So when they make recommendations, they tell you, use this particular service, which is on Azure. But in reality, that's not always the case. Sometimes you have to use AWS, or sometimes you have to use on-prem or your own. So be very aware of that when you make the choices. So, but these 5 pillars is actually just an umbrella term for all the other architectural characteristics that, if you look at it in more fine grain. So when we say on the area of performance, elasticity is actually not the same with scalability. So scalability is like, as your user base grows, you need to be able to scale, whereas elasticity is like when you get peak periods with peak transactions, then you should be able to scale up, and then you should also be able to scale down. So when you make design decisions, that's not the same. So when the business say, what's the difference? And then why is designing for scalability much more expensive than designing for elasticity? Then you have to understand the context and the business needs. And there's a lot of other, very important architectural characteristics, especially around security and balancing security, privacy, also with usability. You don't want to lock everything out, that your users won't be able to, do their job because it's so secured. In operational excellence, you need to also, measure your observability, your portability. There's a lot of these architectural characteristics, and you should be aware of the nuances for each of these characteristics in the context of the domain or the problem domain that you're trying to solve. But the idea is, do not try to design for everything, or it's going to be too heavy, like the Titanic, where all the good features is there. And I think also one of the Swedish ship, there was a ship which was very, very technically sophisticated, because they tried to put all the targets and the SLAs and build that way, and then it sunk because it got too heavy. So understand which of the architectural characteristics that you want to design for, maybe 3, 4, 5 of them, and then focus on those. So I have mentioned that also in the WAF, you can go in. I'm not showing that to you, but if you can go in, use this link, then you can also use the Well Architected Review, which is a bunch of tools. It's like a quiz, a checklist, and you can pick whether you want to test your specific workload or you want to test across or do a review across all the pillars. So how do you score with reliability and security together? And then you have to answer the checklist, and at the end of the review, then you will get some recommendations. What you should not do is answer it within 5 minutes. That's not gonna go. You need to sit down, maybe talk to different, stakeholders and owners of specific components before you do the review. So take time. And some of this reference architecture that we find in the Well Architected Framework, there's a lot, there's hundreds of them, I believe. But we start with a very simple one. This is a very simple architecture for, a very, very simple web application. You can't even see any recommendations on how to, to build the whole network component of this one. So basically, you just deploy an app service plan with one app service that's already exposed in the internet and probably secured only, but not only, because that's also good enough, with an identity management system with Active Directory, and you have all your confidential information in your key vault. You deploy your database, and then some sort of a logging mechanism, like using log analytics and Azure Monitor. Put all those resources together, put it in a resource group, and you're good to go. So that's a very basic and simple web application. Fine, you can live with this, but sometimes you have to live with this. This is, if you will find this in WAF, this is the architecture for a mission critical application. So mission critical being like, if you have like 5 nines, and then maybe you don't comply with the 5 nines, then it can cause massive impact to the business or even loss of lives. Anybody building mission critical, or everything is mission critical? I think that's how it is in architecture. Everything is mission critical, but it's not, because you have to understand also the trade-offs. So, I mean, if you look at this, you have some global resources that you need to deploy, because if you need global replication and global redundancy, it has to be very easy for you to replicate your data across the globe if you have your users all over the world. And if it's not for your users, at least the replication, so you make sure that if 1 or 2 region goes down in a specific area, let's say the whole entire Europe is flooded and everything in Europe is under the water, you can still run. That's how mission critical it is. And then you have, of course, if you want scalability, you're probably using an orchestration and using and containerization. So you have a managed AKS cluster, which is private, which can only be accessed via the Azure firewall that has all the security configuration in place. And if you don't want to do a lot of coordination between your workloads in your services in your nodes, then you're probably building it as event-driven and making sure that you don't lose data because you were not able to process event on time. So in this, it also shows that you can use any event processing, event messaging solution. In here, it's Azure Event Hubs. It could be Kafka. You should have your checkpoint storage in place to mark where you are. So, and all of this stamp should be replicated in different regions or so. You have the monitoring, you have your secure pipelines. So if you want to try deploying this, you can go ahead, and there's a GitHub repo also in the link inside WAF that allows you to just try and deploy all of this and start running your application. It's going to be a very fun exercise. Mindful that, of course, it will cost money, so have to just deprovision everything after you've tested. Anybody has tried deploying this in production? I would like to try. I'd like to try. I haven't myself. So the talk about sustainability. Sustainability is not a pillar in WAF, but I do believe that it is really a driving force that will lead you to fulfill some of the pillars, because you're actually thinking about sustainability. So there is a guideline already in WAF. I think it's pretty new, on how to design and develop applications and workloads on the cloud that is sustainable. And this involves different design methodology and practices across different design disciplines. But what it really emphasizes is that, it's all about cloud efficiency. And cloud efficiency means, lowering costs and being aware of the carbon footprint, our carbon emission for every single thing that we're doing on the cloud and with our application, and the energy usage, the electricity. And not only that, if you're aware of the different scopes of emissions, of carbon emission, you have scope 1, which is coming from the actual activity, so from the actual software. But then you also have the scope 2, for example, the hardware that's running your application is also emitting carbon and also using energy. And then you have the more the harder to compute, which is your scope 3, which is all the other activities involved, all the people using your software, and if you need to transport services, or in your whole software supply chain, there's a lot of other activities that can influence your carbon emission. And in Azure, if you are on EA Enterprise Agreement or CSP, I think you will have access to Power BI Premium that shows you the carbon emissions that you have for all your resources. But this thinking is important in any design areas here, even in testing. How often do you run tests? And if you're doing stress tests, the data that you're using for stress tests or load testing is emitting carbon. So things that you have to be aware of. It's very complicated, and I'm not being preached here saying that I always think about this in my design process, but it sure is a good time to start now. And in the Green Software Foundation, there is a very simple equation. Have you seen this? The very simple equation to compute for the SCI, which means software carbon intensity. So if you can see here, it's quite simple. SCIE is the energy consumed by the software in kilowatts, and then you multiply that by the carbon emitted per kilowatts of energy. And I guess that carbon emission also depends on different parameters like your location, and then you add the carbon emitted through the hardware that the software is running on, and you multiply that by the number of functions. Function unit. A function unit can be the number of users running your software, the number of devices connected, the number of API calls. So how often are you doing your backup? How often are you running tests? So all of this is the R. So you have to multiply that, and you will get some score. So a lot of things to consider, right? Who's responsible for doing all this? For making architectural decisions. What are the different architecture roles that we have to think of? I'm sorry if I missed some titles here. If you have a fancy title, please do let me know. I might be able to put that on the slide. But there are a lot. And sometimes all this title goes to one person. Let's give an award to that person who probably has all this title. Anybody in the room that has all this title on their hat? Yeah, we've been there once. So I think when you're a developer, you also have all these titles. But we also have to understand, the responsibilities, the scope of responsibilities, because oftentimes in organizations, it's really blurred. Who's in charge of defining the security between calling one API with service-to-service calls? It's like if you have two APIs, who's responsible to design that? Is that the developer, or is that who? The security architect? And everyone has a lot to say, especially the enterprise architects. And the enterprise architects. But the enterprise architects are the one who's making maybe architectural decision that is that serves like. Sometimes they're guidelines, sometimes they're policies, sometimes they're hard rules on the organization, what the enterprise architects say. But they're more concerned, of course, of the entire portfolio for their organization. If you're in a large company, you probably have hundreds of different digital efforts and projects, and how do you coordinate them? And also the digital technology that you expose to your customers probably is decided by the enterprise architects, and also some of the long-term decisions for technological strategy, like choices, for example, if we're picking which cloud to use, that's an enterprise architect. If we're picking what kind of event management system to use, are we going for Kafka, are we going for something else? Like recently in one of the organizations I work with, they're supposed to be like they're not very open source, but because of a change in management, suddenly the enterprise architects now have to write all the guidelines so that you are more using open source. So but they make much more long-term decisions. The solution architect is, of course, more well-versed in the specific problem domain that you're building. So let's say in an organization and you're building the e-commerce site, so someone who's a bit more understanding the whole e-commerce domain would be the turf of the solution architect, and how to be able to um, uh, satisfy all those architectural characteristics in the context of that solution, in the context of that domain. So for example, when I design application for an academic institution and I talk about availability, I have to consider when is the enrollment period, which is something that a solution architect for an e-commerce site will not care about. So that's a difference, right? And then you have the data architect who's well versed for all the entire pipeline of the data, from storage to transformation, to aggregation, to analysis, to whatever you do with data. It's the data architect's turf. But most especially maybe data modeling and choosing the right data platform. Security architects, security architect, I think that's very self-explanatory. The cloud architect is a little bit vague. So a lot of us have a title now in a cloud architect, but I also do security. I also understand the data, but I'd like to think, okay, you need a jack of all trades in a bit, right? But you cannot master everything that's on the cloud. But you need someone who's probably very good at putting all the cloud resources together and understanding the repercussions and trade-off, but as well as the costing. What does it cost to use this tier over this tier, and why should I use this tier and not that tier? So for example, if you're dealing with SQL and you're doing with, elastic pools, why are we doing that instead of this? That's more like in collaboration with the cloud architect and the data architect. But what about the technical lead in the team? The people that are actually going to implement your architecture are real people. They're not robots yet. So there you need someone to lead them, to understand, do I have the right skills? Do I have the right communication pattern within my team? Do I have the right team size? That can coordinate all that, so that we can actually deliver what you architects are trying to make us build. So that's more like in the turbo tech lead, and of course the special ones, the developers, who's also in one way or another doing all these responsibilities. No, but all this architecture, remember what we talked about in the very beginning, burnout. Architecture, of course, is for technology, but that, it's still making it very easy for the people who's actually going to implement it to be able to really implement it, and then for the people who will be maintaining it, who will make sure that it is reliable, your architecture is for them, not for your ego. I'm just saying that out loud. So at which scopes do we have those responsibilities? I think this is also a little bit of a repeat. You make decisions on the enterprise level, you make decisions on the actual application, and you make decisions on the component, and you make decision on the supply chain of your software. When I say supply chain, is actually how are you gonna store your source code in your source repository, and then how you're gonna run builds, and how you're gonna deploy them, and what kind of dependencies you're gonna use, what kind of frameworks you're gonna use. That's part of the supply chain, which probably is not relevant so much to the actual application or problem that you're building. So if we make architectural decisions on these different levels, how do we record them? One thing that I find really simple is writing architecture design records, or what you call the ADR, but it's also all about maintaining the ADRs, because you know how it is. Someone writes an ADR in their OneNote and forgets about it, or sends it in an email and then forgets about it. So you also have to have process management and lifecycle management for your ADRs, or your architecture design records. And to make it sustainable to write ADRs, it has to be very, very simple. You don't need to write like 600, or that 600 is probably too much, not even a 5-page explanation of what your architecture is. So you have to learn the art of simplifying why describing your architectural decision. So give it a title. What is the status? What is the context of the problem you're trying to solve? So later I'm going to show you an example. What is the actual decision? This is very important. People change all the time. And I find like I've been working in a project for 5 years, and everyone around me has changed. And then when someone a new developer comes in, they ask, why did you use Ocelot for your proxy? Can you look at the ADR? Then you will understand. And from there, from that understanding, you will have sort of epiphany. Oh, they're building it this way. This is our culture here. This is how we do things. So you have the ADR records, and make sure that it's safe. Together, it's like in in a version controlled repository that you can always access. I'm going to go through some of the life cycle to like, how do we really update this? This is how I see it. How do you know to implement architecture in a more sustainable way? This is more like a long-term one, and this is probably for the technology strategies. You have you identify your technology strategy at an organizational level. You have to refine it. When you adapt, let's say when you do the cloud adoption framework and start adopting different frameworks, you still have to refine it and to understand, measure the effects in different parameters, whether it's, you know, what is the business value that is provide this particular architectural decision in a report, and then again adjust your strategy using technology assessment, maybe looking at the radar, looking 3 years ahead. But this is not agile. This is because technology strategy is very, you know, is very expensive. But on the agile level, when you're building solutions, you can also do iterative architecture. Iterative architecture is every time you do feature ideation at the start of a sprint, make a decision on specific architecture for that particular feature, put that very quickly, spend 10 minutes on your ADR, and start implementing. And once you're implementing, you probably have to say, oh, this one, this particular caching that we have designed for this feature, it's not going to go, it's not going to work. So refine it during the sprint planning, and then implement it and measure the effects. And I think actually during the measuring part, this is when you really understand the usage of the simple architecture that you begin with, and that's where you try to evolve, right? When you measure that, okay, this particular architecture doesn't work, because of the metrics that I measured, then I need to change it. So don't hold on to the diagrams that you have already predefined and colored. So you need to be able to change them as needed. And not just in documentation, but also in implementation. And you do this iteratively as the feature evolves. So for me, again, we looked at the different architectural pillars. What are, you know, the most important things that we need to measure? There's a lot, right? So I'm just going to give a few examples. And in Azure, you have the Azure Advisor. So this basically gives you your scores for those different pillars. And what it does is, of course, it gets data from Azure, scans, look at your activity patterns, and then make suggestion and what you need to fix. So for example, it looks at your cost, and if you can see that this particular, let's say, tier for your app service, you don't really need that because you only use half of the memory, then it can give a recommendation to downsize that particular app service. Reliability, operational expenses, excellence, you get the different scores. But look at this is security, and I scored 64%. Why is that? And let's see, what do we want to measure with the security, right? As a basic in security, you want to have your CSPM, like your security posture. And you need to have a security posture management, and you need to measure your secure score. And also maybe you're interested in looking at your compliance to the different regulations. How do you manage your access management or monitor if there's, you know, if you have assigned owners to an external account, that is a no-go. But you need tooling to be able to understand all this. SLSA, that's your supply chain level security architecture. And that means, you know, I explained earlier the whole supply chain for building software, from writing code to building to using different dependencies and libraries and frameworks. You know, what is your architecture posture on that? So that's also important. So there is a new way for monitoring this using the Microsoft Defender for Cloud. This helps you assess your security score, your posture. It scans again your resources, makes some recommendations, and then sends you alerts. Reliability is also important. You need to have health checks, and if you can, and then design for high availability. Do you need to understand what is your recovery time objective and recovery point objective? But what's really important with reliability is, outside all of this data and metrics, whether your system is reliable, is your user feedback. Because there is nothing more important than the user perception on the reliability of your application. It's more important than monitoring. So your SRE team or logging team can say, well, but it works all the time. I have 100% reliability. But the customer say, it doesn't feel like that. What is more important, right? So you need to have user feedback in place and understand that and design for that. Operational excellence, do you follow the DORA metrics? Do you have a proper support process? Do you have a proper, have you exercised your disaster management process wherein you do backup, you do blameless postmortem, you do root cause analysis, and of course, how is your team dynamics when doing that? Are you the kind of organization that does blame each other when things go to hell, fire, or you stay calm and try to understand and fix the problem together? That's your operational excellence. Cost optimizations, understanding your budget, understanding right sizing, how to snooze your different resources when they're not in use. But more importantly, what is your potential savings? Because this is kind of like a driver for your development team to think about, okay, if I do this, if I turn off one of my VMs, I have a potential savings. And in performance efficiency, measure your latency, the scalability, and very concerned with the geography and even the data pipeline itself, right? So don't just throw data in different, very complex workflow. That's going to cause performance issue. I'm a little bit out of time, but I'm going to try to run through this cloud engineering portal that I have built or helped build for an organization that has 500 plus enterprise products, 3,000 developers all moving to the cloud. And why do I want to talk about this? Because it illustrates that you can use your own tool or build your self-service tool to be able to kind of lead your developers and train them and skill them to be able to build well-architected framework from the very beginning. So I cannot show the portal because I'm a consultant. I cannot disclose it, but I can tell you what it does. So first, it allows you, of course, to imagine what do you want to build. And then in the portal, there is an onboarding feature where you're actually, it's very short. It's like 5 different questionnaires about your business strategy, who's going to own this, do you have do you need an architecture reviewer or not, how matured is your team, and do you have the budget for this, and why do you have this budget? And the thing is, for most approval for onboarding, this is actually sort of preventing the developers to start developing because there's an approval. So what we did is that we automate, once you're onboarded, while you're still waiting for approval, the subscription in Azure is already automatically created behind the scene, so you can start building your sandbox or your lower environment while you're still waiting for the approval. And you can already mobilize your team. You can already set up your environments in this portal, so you can define all your lower environments, dev, test, production, staging. And once you have defined that, you will have access to provision a service principal, service accounts to be able to run your automation pipelines. And then you can assign role-based access control, not directly on the cloud, because this particular company is using several clouds. So you can define the RBAC for your team or for your service principal over the subscription and resource groups that you have deployed. And then you can design, there's a tool for you to design your infra, either using UI or using scripts, and then if you use the UI and you make use of the well architected blueprints and modules available in the portal, then it will speed out the Terraform script, it will connect to your GitHub repo, and it will automatically put your Terraform scripts there and then automatically run the deployment for you. So everything is just within a couple of minutes. Once you deploy, there is also a feature. Also, they have to build it their own and not just rely on one cloud that scans, again, all these resources. They're called beacons, and then they can give recommendation and alert if you are not following some of the architectural patterns or some of you're non-compliant with some of the governance policies that this company takes. And once you get the alert, you as a developer have time to remediate that, maybe apply for policy exception, or they also have automated or automation to be able to automatically do self-healing and remediation for certain types of problems. So all this is built on this self-service portal. And what this does, it brought down the development life cycle from 6 months, because waiting for service now to provision some of these resources, to, I don't know, within a day. Less burnt out. And people learn from each other because they can see how other teams are building their application. And that's the most important. This is an example of the beacons, custom beacons that they're measuring in order to make sure that you're building your application according to the well-architected framework. This is only the security beacons. So for example, in the security beacons, it tells you your container registries are being scanned for issues using the tool, check, but your product has no alerts in cloud security posture management tool. And this one is very generic. They didn't say your product is not using Cloud Defender, because it could be something else. So as an enterprise, you're not locked down to these tools. Unfortunately, I don't have enough time because I have all the architecture that we use this. Sorry, is it like no more time? 2 minutes. It's a very simple architecture, is domain driven, and this is the security architecture for how the service to service call works. We're using HMAC handling. If you're interested in the architecture, do approach me. I can talk to you about it. I'm very passionate with this project. We also have an architecture for how to do a secure deployment or secure supply chain if you are an integrator and building a micro front end, because the self-service portal also allows platform engineers to expose, let's say, there's a platform engineer that exposes AKS and a platform engineer that exposes data mesh and service mesh. So they build all these tools in this self-service program. So we learn a lot in this architecture. And I think some of the lessons that I have learned is that in the beginning, we didn't build for redundancy and scalability. So now we're migrating to Kubernetes. Before it was all PaaS. The API was very chatty. They're calling each other through the proxy, which is the ambassador pattern. We're changing that now to be more event-driven using Service Bus or Kafka. And then there was a long lead time for change because the front end was still a monolith front end. We have broken that down into a micro front end. And what I really learned is that all these huge organizational changes in an enterprise, you change your CTO, your CEO, and how do you become resilient and still, focus on the problem solving and not on the organizational changes that might dictate changes in your architecture. So if you haven't started with WAF, you need to start now. Don't obsess with the patterns first. Try to analyze what you're doing using the metrics. And if there's two architectural pillars that I really want to focus on for now, it's security and sustainability. Because if you focus on sustainability now, I'm pretty sure it's going to drive down your cost, and you're going to understand what is really your performance and reliability need in the context of sustainability. So love your team, folks. Be happy developers and architects. If you want to learn more, let me know. You can find me on Twitter and LinkedIn. I'm starting writing articles about cloud architecture. And thank you for being here with me.